Good day to you from Chem Help ASAP. Let's do a more difficult elimination reaction. Pause the video once I show the reaction if you want to test yourself before the answer is revealed. Here is our reaction. We need to provide the reagents. As a hint, I'll say this could be an E1 or E2 reaction, depending on which reagents you choose. Pause the video here if you want to try it yourself. I'll wait for 5 seconds. This reaction forms an alkene, so it must be an elimination. We don't, however, have a leaving group. Whether an E2 or an E1, we need to have a leaving group. Notice that the alkene is a more highly substituted alkene, the Saytzeff product. Both the E2 and E1 can form a Saytzeff product. Let's start by trying to look at this as an E2 reaction. And we'll see how far we can get. For an E2, we need a leaving group. We could easily use a reagent step to convert the OH to a halide or a tosylate. The halide might require HBr, and the tosylate would need tosyl chloride impurity. I'll choose a tosylate. Once we have a leaving group, we can use a second step to treat it with a strong base. We'll need to use a standard base like sodium hydroxide or sodium methoxide. Remember that terbutoxide would give the Hoffman elimination and put the double bond at the end of the chain. We don't need to worry about doing an SN2 with our base because we have a relatively hindered secondary leaving group. Secondary leaving groups favor elimination with strong bases. So there is our Saytzeff product. So we could easily achieve this conversion using an E2 reaction. How about an E1? For an E1, we still need a leaving group. If we treat this, our alcohol, with a strong acid, namely sulfuric acid H2SO4 or phosphoric acid H3PO4, then the OH will be protonated and made into a good leaving group. Loss of the leaving group will give a secondary carbocation. Its secondary carbocation, not great, but okay. Like any carbocation, we have two options. Carbocations can be attacked, that's an SN1, or lose a beta hydrogen, that's an E1. If we are careful to use just acid without a solvent, then our carbocation cannot be attacked because there will not be any nucleophiles. The carbocation will lose a beta hydrogen, to a base. I normally just use B with a lone pair for this reaction for E1 reactions. Do not think that our base is something strong like sodium hydroxide. This reaction is under acidic conditions. There are no strong bases present. Note that the elimination, this elimination, and especially E1 eliminations, are often heated to drive the reaction. Heat is shown below the reaction arrow, either with the word heat or with the uppercase Greek letter delta. So we can make this product either with an E1 or an E2. I prefer an E2 over an E1, but on paper, both can work.